Hey, Robert hier. Dieser Podcast wird von Keymotion, der Robotiklösung von KEBA Industrial Automation, unterstützt. Wir sagen vielen Dank an KEBA und wünschen viel Vergnügen beim Zuhören. Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Hallo liebe Zuhörerinnen und Zuhörer, willkommen zu einer neuen Folge unseres Podcastes Robotik in der Industrie. Mein Name ist Robert Weber und mir in in Regensburg zugeschaltet ist
Helmut Schmidt, grüß euch.
Helmut muss mal wieder arbeiten, darum ist er nicht in München, sondern im schönen Regensburg.
So ist es, korrekt.
Und in Ostwestfalen ist uns der Millionär zugeschaltet, im Laden. Servus.
Hi, hallo.
Warum bist du Millionär? Erzähl.
Ich hoffe, das bezieht sich nicht auf mich persönlich, sondern ich glaube, es geht um die Nachrichten mit Unchained Robotics.
Ja, erzähl, was ist da los?
Ja, unser Unternehmen entwickelt sich gerade sehr, sehr gut und wir waren in der glücklichen Situation, neue und weitere Investoren für Unchained Robotics gefunden zu haben. Ich glaube, wir sind heute hier zusammen, weil wir bekannt machen möchten, dass wir 5,5 Millionen Euro von, internationalen Investoren einsammeln konnten, um das Wachstum von Unchained Robotics weiter nach vorne zu bringen.
Liest du das jetzt vor oder hast du das jetzt so frei formuliert?
Ich habe das die ganze Zeit vor dem Spiegel geübt, damit ich das hier heute bloß
Pressemitteilung.
Genau. Hey, herzlichen Glückwunsch im Laden.
Gratulation.
Ja, vielen Dank.
Gratulation.
Ja.
Vielen lieben Dank.
Und die legst du jetzt zu 4% auf dem Festgeldkonto an oder was machst du mit dem Geld?
Ja, genau, das wäre ja die andere Variante, die man hätte wählen können. Nee, die legen wir an, um quasi weiteres Wachstum möglich zu machen. Das heißt, man hat das vielleicht in der Vergangenheit so ein bisschen mitgekriegt, dass wir Personalbedarf hatten und jetzt geht das nochmal die nächste Stufe weiter. Wir wollen wirklich stark in Marketing- und Sales-Aktivitäten investieren, weil wir sehen, dass vor allem der Malocha-Bot, den wir zuletzt erst veröffentlicht haben, richtig, richtig gut ankommt. Und das wollen wir jetzt weiter verstärken, denn es gibt Bedarf jetzt schon aus europäischen Ländern wie Frankreich, Polen, Slowakei bis hin in die USA. Und jetzt müssen wir natürlich auch die ganze Organisation so aufbauen, diesem ganzen Bedarf auch gerecht zu werden.
Helmut, 5,5 Millionen in dieser Zeit, Respekt, oder?
Absolut. Sowohl in dieser Zeit, sprich in der Kürze der Zeit, wo es das Unternehmen gibt, aber noch sehr schwieriger in dem jetzigen wirtschaftlichen Investitionsumfeld, das ja nicht ganz einfach ist. Es schaffen nur noch ganz ausgewählte, sowohl Roboterhersteller, also jetzt Plattformen und Anbieter. Von daher muss man sagen, wer jetzt eine gute Finanzierung einsackt, kann oder muss Vertrauen vermitteln und ich glaube, da ist der Laden mit seinem Team gut unterwegs, mit seinem Malocha-Bot, der gut ankommt. Ich hoffe nur, dass dort jetzt halt nicht doch der Integrator am Ende durchschnitt und das Plattformgedanken nicht hinten runterfällt.
Klar, zack.
Nein, da absolut. Also die Plattform, also wir haben ja die große Vision, dafür werden wir ja hier in Ostwestfalen fast immer in den Keller gesperrt. Ne? Aber die große Vision ist, dass jede Fabrik auf der Welt den passenden Roboter über Unchained Robotics gesucht, gefunden und integriert hat. Und das Suchen und Finden, das haben wir schon recht gut über unchainedrobotics.de hinbekommen. Und das Integrieren, da ist der Malocha-Bot ein Teil davon. Und jetzt geht es quasi darum, auch das Ganze in einem Einklang zusammenzubringen. Das Schönste ist ja, das ganze Wachstum, was wir bisher hinbekommen haben, das kam über die Plattform. Die Plattform ist quasi das, wie wir in der Fläche mit ganz, ganz vielen Fabriken in Kontakt kommen und wie man quasi Automatisierung findet. Und jetzt bauen wir quasi den Weg weiter, wie die Integration wirklich möglichst Plug-and-Play geht. Dazu braucht es digitale Prozesse auf der Plattform, ja, wenn man das Ganze weiter skalieren will. Aber es braucht auch ein gutes Setup auf dem Malocha-Bot. Der ist ja nicht nur Hardware, der ist ja auch Software. Da wird es jetzt noch einige Dinge geben, die wir in der Zukunft damit bauen können.
Und das ist super. Ich weiß, ich habe im Laden, dir geht schon immer ein Traum durch den Kopf. Und warum sage ich das? Neuer Robotics eröffnet eine Dependance in München. Agile Robotics zieht in neue Räumlichkeiten in München. UA ist gerade umgezogen in München. Also das Hotspot der Robotik ist in München. Was machst du in Paderborn? Wann kommt Unchained Robotics nach München? Mit dem Geld?
Wir müssen ja erstmal die Flagge hissen hier für OWL, ne? Wir haben ja eigentlich die echte Welt der Automation mit Phoenix, Vago, Weidmüller, Beckhoff haben wir ja quasi auch einen guten Gegenpol hier in Paderborn.
Ja, gut gekonnt.
Ja, also von daher, wir sind hier sehr, sehr gut ausgestattet, was das angeht. Aber ich will das nicht ausschließen, dass wir irgendwann mal uns in Richtung Süddeutschland irgendwann mal bewegen, um das Team auch möglichst divers aufzustellen.
Helmut, jetzt hat er im Laden so viel Geld bekommen. Wo siehst du bist ja auch Business Angel, Investor, wo siehst du jetzt, da musst du aufpassen im Laden?
Ja, nicht den Fokus zu verlieren. Das wäre meine allererste Empfehlung, insbesondere wenn es gilt, eine Produktion aufzubauen oder outgesourcete Kapazitäten zuzubauen, sondern es wirklich an dem Thema, wie es Bladen gesagt hat, die Skalierung der Plattform weiter im Fokus zu haben und dann die richtigen Leute, das Team aufbauen, der Teamset wird schwierig sein. Da wird der ein oder andere wahrscheinlich dabei sein, der nicht passt. Da muss man relativ schnell dann reagieren. Aber ich glaube, da hat er ein ganz gutes Händchen. Aber Fokussierung, würde ich sagen. Das kann mit viel Geld schnell aus dem Auge verloren werden.
Jetzt zum Ende, bevor wir in den Hauptteil schalten, würde mich noch interessieren, wer hat denn jetzt eigentlich investiert? Kannst du ein paar Namen nennen?
Ja, sehr gerne. Also mit angeführt hat die Runde Future Industry Ventures, ist ein Fonds, der sich wirklich ganz speziell auf Industrie, Startups fokussiert, auch dann im Robotics- oder Drohnenbereich. Und mit dabei sind dann auch weitere Family Offices, wie zum Beispiel Techlas Ventures, aber auch Business Angel, wie zum Beispiel der Christian Hülsewig von Schüttflix, also eine Erfolgsstory hier aus OWL. Der auch
Schüttflix, was ist das denn?
Eine digitale Plattform zur Vermittlung von Schüttgut. Auch das muss digitalisiert werden. Die sind raketenschnell gewachsen.
Okay.
Und der Gründer, der Christian Hülsewig, der unterstützt uns und natürlich dann bei Fragen in Richtung Skalierung. Aber mit dabei sind auch wie schon vorher beispielsweise Born to Grow bzw. Zukunftsfonds Heilbronn. Die Heilbronner waren zuletzt in den Nachrichten wegen des KI-Parks und des.
Bist du das alles Alpha dann Ostwestfalens oder was? Faktor 100 sozusagen.
Ja, genau. Genau. Wir müssen da noch reinwachsen, aber also auch quasi dieses Umfeld und auch andere Bestandsinvestoren haben das weiter unterstützt. Also da sind wir sehr, sehr stolz, dass die Flagge weiter hochgehalten haben und gesagt haben, Mensch, die Entwicklung ist mega und dass wir auch quasi neue Investoren dazu gewonnen haben, wie auch die Vent.io, also quasi ein Teil der deutschen Leasing, die quasi als Innovations-Spin-Off quasi in Startups investiert. Und da könnt ihr euch schon mal darauf vorbereiten, dass wenn wir wollen, dass Fabriken jede Fabrik auf der Welt den passenden Roboter sucht, findet und integriert, dann heißt es auch, wir müssen Robotik besser bezahlbarer machen. Jetzt gibt es so viel wie Robotik as a Service, ist alles schön und gut in der Miete. Wir glauben aber auch, dass wir mit einem guten Finanzdienstleister und Partner an der Seite da auch nochmal richtig schöne Angebote schnüren können.
Ach Gott, du redest ja jetzt schon wie so ein Leasingvertriebler von Deutsche Leasing. Das ist ja furchtbar. Was haben die mit dir gemacht?
Nein, ich bin einfach super überzeugt, dass wir jetzt ein richtig geiles Angebot machen können, weil bisher werden Robotik-Lösungen immer in so einem Sondermaschinenbauprinzip verkauft.
Ja, genau.
Und die haben alle Restwert 0 Euro.
Ja.
Und ratet mal, was ein super gutes, modulares, wiederverwendbares System jetzt nämlich schafft, nämlich ein Leasingmodell, so wie es bei den Autos auch möglich ist, nämlich mit einem guten Restwert. Und damit kriegen wir es nochmal ein Stück weit besser hin, unsere Lösung in die Fläche zu bringen.
Gnade dir, wenn du ihn zurückgeben musst. Das ist beim Auto auch immer furchtbar. Ja, ja, sehr schön. Helmut, hast du noch eine Frage? Das mit der Leasing, das hört sich spannend an, oder?
Das hört sich auf jeden Fall spannend an, auch im Anbetracht der, sagen wir mal, der wirtschaftlichen Situation wird mehr und mehr in dem Thema Leasing und Finanzierung unterwegs sein. Ist tatsächlich so, was ist tatsächlich Robotik as a Service, Pay-per-Use, Pay-per-Pick oder eben nur ein Leasing-Modell. Und ich glaube, wenn man da einen starken Partner an der Seite hat, vielleicht auch mit einer niedrigen Finanzierung und Leasingrate, das reduziert gerade jetzt, glaube ich, die Eintrittshürde auf jeden Fall. Also ich glaube, das ist mit Sicherheit ein erfolgreiches Konzept, was ja viele andere auch schon versuchen und anteasern jetzt hat.
Sehr schön. Vielen Dank, Naden. Jetzt gehen wir in den Hauptteil. Vielen Dank, Helmut. Wir hören uns nächste Woche wieder. Schöne Grüße nach Regensburg.
Danke.
Und schöne Grüße nach Ostwestfalen zum Aleph Alpha der Robotik.
Vielen Dank euch. Danke.
Bis dann. Ciao.
Ciao.
Hello, everybody, and welcome to a new episode of our podcast. My name is Robert Weber, and it's a pleasure to talk to Professor Dr. Abhinav Valada from University of Freiburg. Hello, welcome to the podcast.
Hi, Robert. Great to be here. Thanks for the invitation.
Yeah, we are looking forward because we want to talk about RTX, the model by Deepmind. But before we start with that, please introduce yourself briefly to the listeners, Abhinav.
Yeah, great. So I'm Abhinav Valada. I'm a full professor and director of the Robot Learning Lab at the University of Freiburg. So we're a lab, we work on diverse range of problems in robot learning, ranging from manipulation, mobile manipulation, autonomous driving, and etc.
Yeah. Why were you the only German university involved in the project? How did that come about?
I think that's because some of the PhD students here had some existing collaborations with Google Brain, actually. And some of the co-authors, I think, from the Google side already were in touch. There are many, many great, wonderful researchers in Germany. And I think in this case, it was just because we had some contacts with our partners in Google.
Can you describe a little bit what was the research question?
That's a great question. So the research question is essentially, can we create generalist robot learning models as we have seen in other domains like natural language processing or more recently even in computer vision? Can we create these large-scale generalist robot learning models that can then be used for many other tasks downstream? So one of the biggest things that made these large generalist models work in other domains is data, as you can imagine. But if you think about robotics, it's really different.
It's very difficult, right?
Exactly. So because we have diverse types of robots, we have diverse environments that we want to deploy our robots in, we have diverse tasks that we want our robots to do. So to encompass all the possible tasks, all the possible environments, all the types of robots is many permutations of data to collect. Yeah, so as you can imagine, such an effort is only possible if the whole community sort of comes together. And even then, even what we have with these RTX models is nowhere close to what we, really want if we want to create these generalist robot learning models.
But why we should create or generate these models?
Because I think tremendous amount of progress in the last decade in creating task-specific models. And what we have seen in the last few years is we can only get so far with creating task-specific models because it's really not possible to collect a data set in every possible scenario for every possible task. But that's what we've been doing. And that's what we are doing for application-specific robots, right? So we collect a data set for a specific robot with a specific hardware setup, and it works well. And what we've seen is that this still is not really exploiting the entire capability that we can do if we collect a general data set, as we have seen in other domains. So what this paper, I think, has shown, or what the goal of this paper is to show, is that if we create such a large data set, which is embodiment agnostic with different tasks, it enables us to do better than just training on one specific task with one specific robot.
But why do the general model perform better than the specialized ones?
I think this is like similar to any other domain because we cap the structure that is there in the data that is more semantically meaningful than just a specialist structure. So if you can think about collecting a data set in one specific environment and deploying it in the same sort of similar environment, then you really capture the specific structure that is there in this construct that we have with the specific robot, the specific environment. But the general nature of the task itself is not so much captured. You can think of it that way. And yeah, that's what we are aiming to do by capturing large amounts of data in different environments. So we don't want to learn environment-specific or robot-specific information, but rather we want to collect general information about task agnostic, environment agnostic, which then you can exploit better for, one specific task in the end.
You mentioned tasks. What tasks are we talking about? What applications?
So here we specifically, in the RTX models, we specifically deal with manipulation in the sense that you have a robot arm that's doing a bunch of tasks given language instructions. So this can be things like pick up an apple from the drawer and place it on the counter, or pick up an orange and put it inside a drawer. So these are instructions that we have. And with these instructions, we have images of the robot doing the task. And what we do here to teach the robot to do these tasks is imitation learning. And then the goal is that the robot should basically do the actions that is described in these language instructions.
Can you please describe for our listeners the experimental setup? What was the experimental setup like? How did you proceed? And which robots did you work with?
So here in Freiburg, we have our Franka Panda, which is the manipulator arm.
Oh, it's quite famous in these days, right?
Yeah, it's really, really famous. So we have this setup with, I think we have 2 drawers. We have a sliding door. We have some push buttons. And so this is some work that we have been using for quite some time now with language instructions. And this work was initially done by Oyer Mess and Chengwang Huang, who are 2 PhD students here. And this setup was basically used to collect data in our specific setup in Freiburg. But this is just one out of more than 22 odd setups that's been done by different labs in different parts of the world. And each of them are very, very different. So there are other types of manipulators, but there are also quadruped robots. There are bimanual robots, as in having 2 arms. So this is really, really different types of embodiments, very different types of task setups.
But how do you combine these different setups?
So that's a great question. So one of the goals of this paper was essentially defining a paradigm for collecting data. So this data format in this paper is called RLDS format that was initially, I think, proposed in a different paper. So the paper was called An Ecosystem to Generate, Share, and Use Dataset in Reinforcement Learning. And this paper initially defines this format, and we adopted this format. And also we stored data in something that's called TF Records, which is database format from Google. And so everybody collected data in this format and stored it in this database. So that's also sort of a definition of data collection that's used by everyone in this paper.
What is so special with this format?
I mean, there are many formats in the literature, like many existing data sets use different formats. I think one reason is because in other domains in reinforcement learning, this has also been more and more used. So it was just easier to adopt in this case because it's sort of converging towards many existing data sets use this. And TF Records is basically a data format that's easily, very fast accessible. It was developed by Google, initially used in TensorFlow, but now it's also used in many other deep learning frameworks.
You mentioned already the results. Did the results surprise you?
Yes, because I think in other domains such as natural language processing or vision, you don't have so much of variation in terms of tasks, modalities, embodiments, environments. So I think in computer vision, if you compare it, you have tasks and you have environments, of course, but now you have another dimension of embodiment. So you have, this just increases the amount of permutation that you have. So I think we definitely had a lot of hope, but did not expect that much improvement considering the amount of data that we have is still not remotely as much as what you have in vision or natural language processing.
How big is this beta set? And did you also use synthetic data?
So just to go over the numbers, I think it has over 22 different robots, I think about 500 different skills that amount to over 160,000 different robotic tasks. Those are some of the numbers. And I think the data, it's over 1 million types of trajectories that the robot has, that the robots are performing. So yeah, you can think about it as 1 million trajectory is that the arms are moving over 1 million.
So no synthetic data.
No, in this case, it's all real data.
I want to come back to this transfer because robots are very complex systems. Is it really possible to transfer this general, I would call it baseline model or whatever, foundation model? Please just explain it to me once again. How difficult or how easy is it now to transfer this model to a robot, to a different robot, maybe not to a Franka, maybe to a Yaskawa robot?
So that was the whole premise, that we wanted to prove that this leads to a positive transfer. So what we've seen in the last, I'm sure you must have heard about this concept that's called sim to real.
Yes.
Which is also a problem where you train a robot in simulation, because we can create infinite amount of environments with different robots, different tasks. So we can also collect such a data set in simulation, but then you have this problem of sim to real transfer, in the sense that a simulation is not as accurate as possible as collecting a data set in the real world. So then we have to adapt this model to, a real robot with real physics and real things that the robot has to deal with, which is not modeled in simulation. So in this case, if we collect real data, you don't have this problem of sim to real, but rather you have this problem of adapting from different embodiments. And really that problem is not even tackled here in this work. So in this work, it only collects diverse data and trains. So I think in the future, what you would see is many follow-up works that, try to reduce this domain gap between different robots. There are many techniques in the literature to do this. But here, what we showed that it's even possible to just take all of this data in a general format. And here, Google basically trained 2 of the models that they have existing, and they just trained it on this large data set. And they showed that in one case, it led to, I think to be exact, it was like 50% success. And in the second case, the RT2 model, it led to 3 times better performance than only training on the initial data that they did in their first paper. So this just shows us that collecting real data from diverse embodiments is extremely beneficial.
So you already mentioned a vision and you already mentioned ImageNet. Is this the ImageNet moment in robotics?
I would say so. I think this is the beginning of the ImageNet moment. I'm pretty sure that what this work has sparked is just the beginning. And now that we have this format available and we have shown this, the entire world can contribute to this data set. So it doesn't stop here. So anybody can...
Is it open source?
Yeah, exactly. So anybody can, adopt and collect more data with their own robots that they have, and they can add to this data set, and this hopefully would become much larger in the future.
So the idea is to build a foundation model on robotics, right?
Mm-hmm, exactly.
Now our podcast is called Industrial AI Podcast, and we invited you, Abhinav, to talk about this model. But what does it mean now for the robotics companies, this foundation model? Is it a threat or is it a chance for them?
I wouldn't say a threat. I think it's always, if you see something in research, it's always a chance to...
As a researcher, sure.
Exactly, to show what's possible. And I think the industrial use case would be very different from the settings in this data set. So there are some settings where you can apply to, industrial environments, but a lot of these settings are more like home environments or kitchen environments where the tasks are something like cleaning a counter or putting things away. You can also apply them to industrial domains, but I think definitely this is a chance to show what's possible. And if you think about different industrial settings, I'm pretty sure that this also gives hope to companies that such vision language models for robotics can also be created by industry for their specific domains.
Yeah, I think that's the message. It's difficult to build foundation models on specific industrial domains, but it's possible, right?
Exactly. And I think this is only tackles this one sort of setting of vision language robotic models, right? So if you think about industry, you also want to create foundation models that include much more diverse modalities. You want, for example, depth information, you want tactile information, and all of this is not really addressed in this work. So it definitely shows you that including more complex modalities is something that we need to do in the future. So it also shows you opportunities that this is possible.
But can I use this model at the baseline to take the next steps?
Yeah, definitely. That's exactly the goal, I think. Definitely, I'm pretty sure in the future we will see other works that come up which use different types of models that are built on top of these models. Let's say so-called fine-tune these RT1X and RT2X models for different tasks and domains. So that's the adaptation is not really addressed in this work. And how to adapt these models is something that will definitely come in the future, that is called like transfer across embodiments. And this will really improve the performance much, much more.
So your advice to the robotics company is watch this carefully.
Definitely.
Yeah.
And work together to improve this much more.
Can you summarize, please, once again, where's the model is still maybe lacking? Where do we need still more research on this?
Yeah, that's a great question. So in this, there's a very interesting part of this paper which talks about some of the limitations. So this paper basically does not consider that the robots have different sensing and actuation modalities. This is because the input is just the camera, images, the trajectory, and the task description. So it doesn't consider that each of these robots have different sensing modalities. And if you consider this, there's definitely some improvement that we can make. And the study also does not study the generalization to new types of robots. So it only studies the generalization to robots that it has seen during the data collection, but not a different robot that is never seen. So this one aspect is still not touched upon in this work. And it also does not provide any, let's say, decision criteria of what is a positive transfer or when does this transfer does not happen. So these are some aspects that I think we will definitely see, I'm pretty sure, in the next 1 year. I'm pretty sure there's like researchers all over the world who saw this paper and are working towards these problems right now. But I think these questions are very important to address in the future.
I want to come back to this term foundation model or general model or whatever. I want to talk in general with you. Who owns the foundation model at the end?
Great question. So in this case, the foundation model, I would say there are two models, right? So there's this R1X and R2X. So these models were initially developed by Google. They just trained it on the data. So these existing models were just trained on the data set. This was collected from different people. So I guess the model itself, it's not a new model that came out of this paper. So I would say that models are R1X and R2X are from Google. But again, if you have a different model, so there's nothing special in this model that it makes the foundation model, but only the fact that it's trained on these diverse data. So there are many models like this, and we can train any of the existing models also on this data set and make it more open source for different tasks. And I'm sure this will happen in this coming months.
So everybody can use the model and train it with their own data?
Exactly.
But that's a big point, I think.
Mm-hmm. But one question, again, is we need a lot of compute to do this. But I think that this is definitely possible.
What are your next tasks in your department, Abhinav? What are your next tasks in robotics and AI?
So one of the things that we're really working on is to, as I mentioned very briefly before, is to scale this with different modalities. Vision is great, and we need vision to see what the robot has to do in the world. But I think we definitely need more modalities. We need, for example, depth information to see how far the objects are around in the environment, what the robot shouldn't collide with in the environment. But we also need other modalities such as tactile sensing data. So when a robot is grasping an object and doing things with this object in hand, the tactile information is very, very useful. So we are working towards integrating more diverse modalities and to create let's say, like a foundation model with diverse modalities beyond just vision and language. And we truly believe that this will further improve the capabilities of robots in the future.
At the beginning, I asked you why you are the only Germans in the project. And now I ask you at the end, what is our position in the robotics AI world from a European point of view? What is your opinion on that in research and when you combine it with all your colleagues in the US?
So I think there are truly many labs in Germany that are on the forefront of robot learning. And many of these labs are doing very great things that are, I would say, even beyond, much beyond in different domains than what you might see in industry, in Google or other companies. And I think this is one domain where we are, let's say, on par, even better than many places. And I think this has a long history of having very strong engineering background in Germany. Yeah.
Okay. So do you think is research coming back to the universities because Google and the other big tech companies do not want to share anymore all their results? What is your opinion on that?
So I think research never left academia. So there are some domains where we have seen industry get involved much more, but there are some domains where industry doesn't really do research on. And this again, industry does research because they see a direct application to products, right? They still don't do entirely open blue sky research, which is only possible in academia. And we've seen some really great things from industry pushing forward certain domains. This has also helped us do more research in different directions, even in academia. I think like some industries also open source their research that they do, not necessarily for commercialization purposes, but for research, they still let their code open source, further develop on this.
But it is easier for you now to find PhDs, maybe in the future?
Well, it's always a challenge. And I think the way to attract talent is to show them that truly interesting blue sky research is only possible in academia. We have the freedom to do this. We're not, let's say,
dependable on money.
Depending on product teams that want tangible products out of this. I think like this is still only possible in academia.
Abhinav, it was a pleasure. Thank you very much for explaining us the RTX model by DeepMind and your role from the University of Freiburg. Thank you very much. It was a pleasure.
Thanks a lot, Robert. It was great talking to you.
Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber.